In this video, let us explore the equation of circles in general form. Let's turn to page 111 of your notes. Point 1. Expand the entire x plus 3 square plus the entire y minus 7 square equals to 36, and you are to express your equation in the form of x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Now the assumption is that x and y are the variables while g, f, and c are constants, are numbers. Let's expand and see what we get. X plus 3 squared plus y minus 7 squared equals to 36. Upon expansion, I'll get x squared plus 6x plus 9x, plus 9, no x. All right, plus the second bracket upon expansion, y squared minus 14y plus 49 is equals to 36. Let's rearrange it to look somewhat like this line here. So I get x squared plus y squared, yes I do, plus 6x plus, nope, not plus, minus 14y. And then now I'll deal with all the numbers. I have a 9 plus 49, 9 plus 49, and then I will have to minus 36. All in all, I get a plus 22 equals to 0. All right, if I want to write it a little bit like the constant, or rather the format above, I get x squared plus y squared. 6x, if I were to split it into 2gx, essentially it is 2 times 3x minus 14 if I want to split it to positive 2f. Nope, not f. F will not be 7, but in order to get a negative 14, I need a negative 7y, and then plus 22 in this case. All right, if I were to write this in a mirror of this box here, or rather this format here, all right, and I compare these two, I will notice that actually my G is equals to 3, my F is equals to negative 7, and my C in this case is equals to 22. All right, carrying on the activity, let's go to decimals.com and plot circles whose equations are given in the following table. And then later on, we can actually find the values of g, f, c, and the relationship g squared plus f squared minus c, and draw some conclusions. Let's go to Desmos. Now on the left-hand side, you see your notes, while on the right side, you see the desmos.com/calculator as indicated in your notes. Let us look at our notes here. We have an equation of circle x squared plus y squared plus 8x plus 10y plus 16. Based on the format above, all right, where we can actually write this way. Based on the format above, where we can split the constant, or rather the coefficient of x into 2 times something, and the something is actually your g, and then the coefficient of y to be split into 2 times something, where the something is your f, and then you have a constant as your c over there. Let's use point A and see what is your g, f, and c in this case. If I were to split 8 into 2g, I know that 8 essentially is 4. If I were to split 10 into 2f, I will know that my f is 5. And then in this storyline, my c is 16. The second one, b, all right, if I were to split 3 into 2g, I will know that my g essentially is 3 over 2. If I were to split my negative 4 into 2f, I will then need my number to be f to be negative 2, because negative 2 times 2 will then give me my negative 4. And then in this case, my c is as good as minus 6. For part C, my negative 5 to split into 2g, I will need to have my negative 5 over 2 times 2 to get 2g. Then I have my negative 9. If I were to split, this will get me negative 9 over 2y. All right, and then this one is a positive 51 over 2. In part D, I have a negative 7. And if I split my negative 7 to represent 2f, all right, if I have my negative 7 to represent 2g, I know that this is negative 7 over 2. All right, if I have my y, note, this one does not have y. Essentially, your 2f is now as good as 0. All right, and note that this is negative 3.75. Negative 3.75. Okay, my eraser, not 3, but negative 3.75. Or maybe let me change this to fractions so that it's easier for all of us to see. Negative 3.75 means negative 3 and 3/4. If it's negative 3 and 3/4, we are talking about negative 15 over 4. All right? And then this one doesn't have a 2g. It has no coefficient of x. There's no x there per se. So my g is 0. And then my f now is 9 over 2. I have to further divide it by 2. So this is 9 over 4. And then my c essentially is 7 over 2. Now with the table of values, let me calculate g squared plus f squared minus c. Pause your video and you can actually press your calculator to find the values for A to E. I hope you have attempted the calculation. You should be able to get these values: 25, 49 over 4, 1, 16, as well as 25 over 16. Now, bearing in mind these values, let's go to decimals and see how each of these circles look like. Let's look at A. A can be found over here in this red circle. If we noted that every line represents 1 unit, every line on the y-axis also represents 1 unit. Now, if from the circle is from here all the way to here, so we know that that's 10 units. If I were to find the center, I would probably guess that my center is actually here. All right, my center of the circle is over here. If I were to look at the center of circle and read the coordinates, I am looking at negative 4, negative 5. So I'm going to put that in my notes. Negative 4, negative 5. That's the center of my circle. Now, if I take negative 4, negative 5 here, all right, and if I measure the length of the radius, that's 1 unit, 2 units, 3 units, 4 units, 5 units, I will see that my radius of circle essentially is 5 units. All right, that's for the first one. Let's go to the second one that we have. All right, the second equation, we have x squared plus y squared plus 3x minus 4y minus 6. Let us look at this circle. If I look from bar to bar, I'm looking at possibility of, say, here. All right, if I look from top to bottom, I'm looking at possibility of a center circle here. All right, if I look at this center circle, it is essentially negative 1.5, 2. Negative 1.5, 2. Let me put it down. Negative 1.5 and 2. All right, negative 1.5 and 2. If I were to measure the length of this radius, negative 1.5, 2. So if this is negative 1.5, I'm talking about 1 unit, 2 units, 3 units, 3.5 units for my radius. 3.5 is the same as 7 over 2. All right, let's look at the third circle. All right, the circle in green, let me expand it. Aha, now the scale is a bit different. Let me try with this scale. I think it's bigger and clearer. From the look of things, we can see that if I look down my axis, this is 2.5. My x value is 2.5. If I look across, I'm talking about 4.5. 2.5 and 4.5 for my center of circle. So let me put that down. 2.5, that's 5 over 2. 4.5, that is 9 over 2. All right, if I mark this as my center and I actually go and calculate the length of a radius, this is 1. So if this is half, if I calculate, this is 1.5. Over here, the coordinate is 1.5. Over here, the coordinate is 2.5. So my radius of circle essentially is 1 unit. If I go to my fourth circle, let me shrink this a little so that's for ease of reading. I will notice that if I look across the diameter, all right, if I look across the diameter and I look across the diameter horizontally, I do expect that my circle, all right, is ranging at 3.5 for its x value, and then the y value, this one will be 0. So let's put that in my notes. 3.5 and 0. So if I do my calculation, that's about my length. This is 3.5, and then all the way over here is minus 0.5. So if I go calculate, my length of my radius is about 4 units. Let's go to the last one, the black circle I have there. Let me expand for ease of reading. All right, from end to end, I know for sure the center has to fall on 0. So let me put it in. Then where is the center? This is 1. This is about 3.5. If I go through and count, take 3.5 minus 1 and then divide by 2. My center of the circle, it falls at negative 2.25. And if I were to go and measure and calculate the number of squares I have, then we can see that the radius is actually 1.25 units. Now focusing on the notes now. If you observe the table you have above there, by just observing the various columns of the table, what can you say about the center of the circle in terms of how is it related to G, F, N, or C? All right, now if you look at the values that we have, this is -4, this is -5. We had a 4, but +4. We had a 5, a +5. Now, if we look at -1.5, the center, and 2, the center for the second circle, we notice that we actually have a +1.5, and over here we had a -2. Observe again the third circle, 2.5, G was -2.5. Center of circle, 4.5, the F value is actually -9 over 2. So if you compare and contrast the table, we observe that the center of circle essentially is the negative value of G and the negative value of F. Let's observe another point. Shrink this smaller, bring it up further. Just by observing the values the values in various columns, let's observe the radius of circle. Now if you notice, this is 25, this is 5. This is 49 over 4, this is 7 over 2. This is 1, this is 1. This is 16, this is 4. This is 25 over 16, you have a 5 over 4. You will then therefore be able to conclude that the radius of circle is actually the square root of our G square plus F square minus C. In conclusion, when equation of circles are written in general form, note what is the G, what is the F, and what is the C value in the equation. Once you're able to identify the G, F, and C, you can actually write down the coordinates of center of circle as well as calculate the radius of circle with minimal hassle. Let us go to more examples and we can see how this will help us in our forming of equations and calculations.